Ladies and gentlemen, dear speakers, dear participants, a warm welcome to the second webinar, which nests itself within our Smart Manufacturing Week series of 5 interactive webinars. A quick overview of this week's agenda. This webinar is going to be moderated by Jean-Paul Hengen, co-moderated by him and myself. Here's the agenda. So please know that we have daily webinars from 11 to 12. There was one yesterday, so the introduction to EU trends, digitalization and sustainability. In case you missed that, you can now watch it as a replay. For the detail of this session, digitalization and automation have enormous potential to improve manufacturing processes. This webinar focuses on robotic process automation, RPA, for production lines and will provide concrete examples on how to apply automated quality controls and integrate robotics in the construction sector. We will also hear about how research projects can facilitate the digital transformation process of manufacturing industry. We will then also dive into the IoT side of things and discuss new technologies and potential risks and security. So before we get started, here's some guidelines for this webinar to familiarize yourself with the tool. On the right-hand side of your screen, you will see those 4 icons. The one which is highlighted there in the red square is to meet providers. So feel free to click on the coffee cup, meet the service providers at their digital booth, and be able to view and download documents as well. The other side, you'll have 4 more icons. So you'll have one which will situate yourself in the webinar with a picture or maybe not. Then there's a Q&A box with a little icon and a screen, so a little man and a screen. That part will be specifically interesting for you after our presentations. So feel free to send in your questions in the Q&A section, and our moderator, Jean-Paul Hengen, will then take over and do the Q&A session with our speakers and ask the questions directly. The next one down is the polling button. So we'll ask you a few questions as well to get you started in this webinar and make it more interactive. The last one down, which is highlighted in black here, is the people button. So there you'll see who's actually present in this webinar as well. And you can see their names in the list, whereas there's a list of people and presenters. So for this webinar, we'll have presentations. So we'll talk about EMS or in-house electronic manufacture, challenges, trade-offs, practical from spot on the construction side, the generation of digital twins of construction sites with autonomous mobile robots, new technologies, old risks, the IoT, in and security, and then closing, which will be done by Jean-Paul Hengen. So before we get started, there is all in the lobby part, there is also a video, a welcome message from our minister, Franz Fayot, which feel free to click on, and you'll be able to have a look at what he said and recorded for you. He explained that smart manufacturing is a specific application of the industrial Internet of Things, the IoT, that allows to produce sophisticated high-value products machined to individual customer specifications, profitably again in countries with higher salary costs such as Luxembourg. He also went into detail into specific supporting schemes in research development. So in case you missed that, feel free to click on the replay, which you'll see on the left-hand side in your activities bar. So moving on to our speakers for today and the program that we have today. We have 3D scanning specialist, Artec 3D, who will share his experience of implementing an in-house automatic PCB assembly line and describe the challenges and trade-offs for the company. And for that part of the presentation, we'll now welcome Alexander Sharapov, who's the VP of Research and Development. Over to you, Alexander.
Let me share my screen. So, yeah. May I start?
Yes, go ahead.
Yeah, my name is Alex. I'm responsible for the electronic design and all the hardware design and process engineering at Artec. Today, I would be happy to share my experience how to build the in-house manufacturer for PCB assembly line and some trade-offs and challenges you may have on this way. So, how in ideal world the interaction between the EMS company and customer look like, and maybe how the in-house manufacturing line may look like. So what is between the difference, the similarity, and trade-offs? First of all, let me introduce what we are doing, what for all of that. So you can see our old devices application, so how it looks, how it works, and what for. So we are making the handheld scanners for capturing 3D data of the objects. Have very different applications, starting from the reverse engineering and ending by the medical application for prosthetic making and etc. So it's a little funny video that explains what we are doing. So we decided 3 years ago to switch to our own manufacturing of the PCB assemblies. Why? What happened at that time? That's our device. So you can see the level of electronic design and our old devices. So we used that time AMS for PCB assembly, and minimal chip size was 0.603 in imperial units, the minimal pitch 0.5. It's quite simple electronic design, so it's not very hard to reproduce. So what happens now? Now we are making more complex design. So you can see our modern device. So it has a computation unit, our homemade designed inside. So for very, very fast image calculation and stitching together the 3D surfaces in real time. You can see it right on the screen of the device. So it's quite powerful device. It contains 5 rigid flex PCB and 5 complex PCBs. High-speed design. Smallest component is 0201. It's quite challenging. It's not smallest one, but yeah, it's not easy to reproduce anymore. The smallest pitch is 0.35 millimeters, and very modern packages of the components. So, fab or fabless? That's the question. To have a chance to charge, let's go through the PCB assembly process and take a look how it works, how it looks like. So the PCB assembling process, there are 2 main branches in. Through hole, it's old-fashioned style, and surface mount technology. Why surface mount technology is more popular now? Because of automation. But the through hole is still very popular in some particular cases. For instance, we are using this technology for some connectors, some external connectors, because of very high mechanical stability of these parts. You know, the customer may break some external external connector, like a power connector or Ethernet connector, because of force, and it allows us to make more reliable devices. However, SMT is more attractive from the automation point of view, and you have a look, you have a chance to see how looks the SMT line in general. So, three main stages of the SMT process in the red areas. So, SMT line in itself, what is it? The minimal SMT line contains three machines: stencil printer, the pick and place machine, and oven. So first of all, the solder paste should be applied on the pads on the PCB, then components placed over on the PCB over the paste, and then it should be reflowed so the solder will melt. Yeah. So the first stage, the applying of the solder paste printing, you can see how the screen printing is working. So it's most challenging thing because you will see it later. The quality of this process is most important for the quality of the final product. So the solder paste is applying through the mask onto the PCB. Then solder mask and PCB separating, and PCB is going out from the printer. So the pick and place machine using the visual system to see the components from beneath to align according to the right position on the PCB. It allows us to reach the good positioning plus minus 30 microns. So it's good enough for modern components, for modern pitch and so on. So how looks the process? So it's really spectacular. You can see how we assemble our main PCB of the Leo device. So after all the components placed over the board is going to the oven where the temperature is going high, and solder melts, applying the solder joint between the PCB and component. So at the right side of the screen, you can see how it looks like. Unfortunately, you cannot see it in the real oven, only in the lab. So the most typical defects you may see during the production. The missed components, it's easy. For some certain reason, the component was not placed on the PCB, or maybe washed out with a heat of the instrument or another component if your design is not meets the capabilities of the machine. So another story is the process problem, is the Tombstone or Manhattan effect, when one of the sides of the chip component may not have a solder joint at all. So it's one of the beach of the process. It's a big problem. So another problem you may have is a head in the pillow or head on the pillow. It is a problem of the BGA components or other modern components that already have a solder on the lead. You can see the cross section of the solder joint, and you can see that these components have no real solder joint. It's 2 drops of solder without any reliable connection. The problem of this defect that your device may work for a certain time and stop working afterwards because of oxidation or mechanical defect. Unfortunately, you have no chance to see it at all. Another story is intermetallic compound that may lead in other problems like cracks in the solder joint. So we're talking about some particles or some different suballoys in the solder joint. It is one of the problems of the process of the choosing the right materials, the temperature profile, and different other parameters of the process you should take into account. And finally, it leads the cracks. So the cracks may be the reason of wrongly choosing the thermal profile, the time of the process, the material, etc., etc. The reason why we have such defects, why we should meet it. First of all, because of the wrong design. So it is not about the process, but about the design. If you have the manufacturer as AMS, you will never know that you do something wrong. So it's a big problem. Another story is wrong process parameters. I just talked about it. Wrong materials and condition, and wrong equipment. Because your equipment should meet the capabilities you need to reproduce your PCB. So the cost of the defect, as much as longer you don't see it. So most of the defects appeared during the stencil printing. So, and it's easy to fix it because you apply the solder paste, you can wash it away and start again, no problem on it. However, when you place it your components, the cost is going up. When you solder it, it's quite complicated to rework. So this way, the cost at the end of the process is maximum. So we've considered 3 stages of the line, and the minimal line without any inspection. I never recommend you to do that without any inspection. Let's see what we should inspect after each stage. First of all, we should inspect the solder paste, how it's applied. So the machine calls SPI, solder paste inspection machine, 2D or 3D. 3D is definitely better. AOI, pre-reflow, so how the pick-and-place machine places the components, and post-reflow, how it was soldered. It's very important stage of the checking. And XI, so it's X-ray. It's very important for controlling the head-on peel or other hidden defects that appeared on the very, very modern components. So SPI, you can see the 3D way of checking. It allows us to check not only the area of coverage of the solder paste, but height and volume. It is very important, in fact, from the point of view of defects that may appear. So AOI, how it works, it looks onto the assembly PCB and checks if the component in right position, if it has the solder joint, of course, only in those cases if the solder joint is visible. Otherwise, only AXI, so X-ray machine, may help you to see it. The X-ray machine we don't have in our internal manufacturing, but we will be happy to order it, and we have a plan for that for next year. So function testing. So after you assemble it, your PCB, you should test it. You should see how it works, that all the functions are okay. It is a typical installation we're using for checking our boards. So there are many works, the hand works, and so on. How it should look from my point of view, and we are going to order this machine. Unfortunately, it's very cost expensive. Fly probe machine. It covers up to 100% of the functional testing of the board. So it's the best way how to check it, and also how to program if you have some flash memory or some other memory devices on board. So returning back to the question, fab or fabless, we should consider different things. First of all, the volume of production. Many years ago, we found that some trigger, like 1,000 units in a batch, may make your approach to establish your own fab more or less efficient. However, the design complexity, it's very important thing, because if your BOM of the board, for instance, 100 euros, maybe you need bigger volume. However, if the BOM of your boards, for instance, 1,000 euros, even some hundreds boards may be enough to establish your own manufacture. And definitely the technology involved, so the component time, the packages, may have effect on your choice. So it's not easy. There is no very easy rule how to do that, but you should take into account anyway. So what you have if you reach your own manufacture. So it's controlled environment. What I mean when I write down these words, if you order your PCB assembly in AMS company, you never know which process parameters they use, which defects may have your board. You should control it. You should check it. Sometimes the checking of the board may be more cost expensive than manufacture of them. So another story, you may have the full traceability. I mean, first of all, you have a record of each stage of the production for each serial number of your board. It's very important for automotive, for medical devices, for aerospace and military, but for other complex designs, it's also may make sense. Yeah, and definitely you will have the flexibility if you have in-house R&D process, because otherwise, even to make your prototypes, if you have some modern components and modern technologies, you should wait list maybe some months before you make your prototypes. So you can plan your production more efficiently. So that's all I would like to share this time. If you have some questions, please ask. Thank you.
Thank you very much, Alex. Thank you for this fabulous presentation. Before I pass over to Jean-Paul for the Q&A session, maybe reminding you that I've seen that some of you have already used the poll part of this webinar. So with answers coming in, just to remind you, there was 2 questions that were put in the poll. How far would you say your company is in terms of digitalization? And you have 4 selections that you can make: 0 to 25, 25 to 50, 50 to 75, or 75 to 100%. And the question below that, do you see digitalization as an opportunity or as a threat? So also giving people more time to send in their questions to the button above the poll button. And then Jean-Paul can then grab those questions and ask them directly to Alex. Thank you very much. Over to you, Jean-Paul.
Thank you very much, Mark, and especially thank you also, Alex, for this presentation and the details of your production line. But when I look into such an installation, how long does it take to be really efficient with all the quality controls in place, etc.?
Yeah, it's a good question, because you should be aware that after installation you have some time for establishing the good process, and it depends on knowledge you already have, and knowledge not only about the process but about your machine. So for us it was about
Okay, thank you for that. And the other question for me is, well, you mentioned in your presentation that you need to use the right equipment. What do you understand by the right equipment, and how can I identify if it is the right equipment?
Yeah, it's also a very good question, because you have no chance to guess. There are only 2 ways how to understand it. It's trial and mistakes, or you may find the dedicated guy who knows the equipment well. So there is no.
Okay, thank you very much for that. Mark, then I hand over to you back for the next presentation, please.
Thank you, Jean-Paul. So yeah, moving on, we're now going to have Joël Schunz, the CEO from Stugalux Constructions SR, who's going to do a presentation as well. So Joël, by means of introduction, in recent weeks, people might have witnessed some strange creatures or animals running around on construction sites. Would you care to explain what that was all about?
I will do my very best, and for this I have prepared a few slides. Actually, what the whole process started at Stugalux a few years ago, when we defined our process as being something like a caterpillar. We have basically the masonry, the roof, the ceiling, HVAC, windows, up to painting, landscaping, all within our company. And so we basically eat land. At the end, there's some housing coming out. To give you a little perspective over the all market in the European Union, 9.5% of the GDP is construction. And it's civil engineering, non-residential, new residential building, and rehabilitation, in French you say transformation, and maintenance. So almost half of it is always composed by housing projects, either new ones or old ones. This is a video I added, and I hope that it's working over the video conference system. What I wanted to show you is that the process of these strange objects that are working now on our construction site, actually the video started was made in 2018. So in 2018, we presented this at the Autodesk University in Las Vegas to show the integration of our BIM models with our ERP system. And you see that the windows that are always selected, they are really windows. So you have properties of it, and the BIM model itself, it's basically like if you have programmers, before you had C, now you have C++. So you're really talking of objects, and you have different properties and all different kinds of puzzle pieces, how you put your construction together. And the next problem actually arises then, this is wonderful in planning, but how do we check this one on site? To me, the robots on site would not work if we would not have a 3D complete model of everything that you need to see. It's like if you have GPS coordinations without a map. It's not very interesting just to document these different things. A problem that is still arising a lot with BIM, and I want to mention it to be complete. The official norm is IFC, and the exchange is pretty bad, I must say it like this, but it reminds me of my beginnings with SQL servers 20 years ago. It was also very, very difficult to transfer one database from one system to another. We will survive that one. What are we actually doing? We are harvesting the data on the construction site, and we try to compare the point cloud that we harvest on the construction site to our BIM module. With the robots, we're going to get hundreds of scans on a daily basis, so we're going to get a lot of construction data, and we also see where the electrician put his cables, where the heating HVAC put his pipes, and so on. So that's very, very interesting for us on how we can go. One of the questions we had for the robots was, is it legs or wheels? To me, it is only one answer can be the correct one, and that is that we need to have legs, because you see a typical construction site, and that's something where the wheels would definitely have problems to follow through, and to go the stairs, to walk over these kind of iron bars and all the rebars. That's something that's very important to me. We have some problems. So if you put a large pipe in the way, the robot doesn't like it. If you put a pallet on the other way around, on the regular way, has no problem. But this is actually to protect a pipe that we use to do the shop. On that one, to protect that one, but if it's in the way of the robot, he doesn't like it at all. And I am very, very happy that here the paint was closed, because he would have basically stepped in the paint and thrown the paint around on so we still are working and testing and getting it up and running, but I must say we are very, very happy for the moment with the results that we get. What are the points of results that we get? We get point clouds. This is an image of a point cloud, and you see the lines of the laser on the image, and that is basically a trade-off we are doing between the speed of scanning and the accuracy. If you take a lot of time in the same room, then you get a very, very millimeter accuracy, and it's very, very detailed. And but if in this site here, we were basically just doing the walls, and so the accuracy, if it's a centimeter, it's still okay. If it's the difference between 2 and 3 centimeters, then we have to get a warning. So the speed of scanning is usually the trade-off between accuracy and the thing. And then another problem that we have still for the moment is where to go. So for the moment, we still have to set up, and this was actually the first plan we did in June, where we simply had, and it fascinates me that all our guys who are working with robots are still using pen and pencil to define the way how the best way to scanning it. And the technical term, to me, it's a Chinese postman problem. How do we most efficiently find a way to get this up and running, and how to scan this apartment in the most efficient way? And also, what I don't know is what happens if we have to exchange this plan between a drone, a robot, and a different robot. Because I can tell you now already, this is not the last robot that you're going to see at Stugaluk's construction sites. That's basically from me. If you have any questions, don't be shy and just go on and ask please.
Thank you very much, Joël, for this presentation. Very interesting indeed. So it was obviously a real-life example on construction sites, and also there's a collaboration there with the Automation and Robotics Research Group of the University of Luxembourg, of their interdisciplinary Center for Security, Reliability and Trust, the SNT, which leads me on to our next speaker, who is Holger Voss. Holger will be joining us to speak in more detail about sort of this research aspect. Holger, to introduce you, you're a full professor at the University of Luxembourg and head of the Automation and Robotics Research Group in the SNT. You have more than 20 years of experience in mobile robotics, both in the industry and academia. Your research group is active in many areas of robotics, such as drones, robotics in Industry 4.0, autonomous driving, or even space robotics. This next presentation is about the research collaboration we just mentioned between your group and the company Stugalux in the area of mobile robotics in construction industry. So I'll let you prepare your presentation and put that on the screen, Holger. In the meantime, if people, an interesting or important aspect of these webinars are also the networking part. So on your left-hand side, the third button down, you have various rooms where you can also afterwards network with people. So don't miss that opportunity. And handing over for this presentation. We'll do a joint Q&A after Holger's presentation, so people can then ask questions to Joël Schons at the end of this presentation. Thank you. Over to you.
Yeah, many thanks. I hope you can see the slides.
Yes.
So yeah, okay, great. Yeah, as you say, many introduction, as you say, and as Joël was already saying here, this is about a collaboration, and I think I gave a very great introduction into the topic from the practical point of view. It's now about the generation of digital of construction sites, however, now with autonomous mobile robots. That means, as Joël was saying, at the moment, even with the robot, the people are still using pencils in order to do the planning, in order to operate the robot. Of course, what we're working on, or together, is how to increase the degree of autonomy for these robots. So as Joël was explaining, the basic problem is, you can imagine on the one side, we have the digital constructions done by, for example, the architect, planner, and on the other side, you have the real construction site. And the big construction is to see whether the ongoing construction is following the construction plan. And this is really, you can imagine, everybody who has already knows that, and it is really difficult to the idea here is to fuse the information from the digital construction plans from the BIM and the 3D scans from the construction sites, and to fuse that into a digital twin. And as Joel was already saying, currently this is now the first idea to do that. And the core of that is to use, as you can see here on the right-hand side, to use laser scanners for the 3D point cloud generation on the construction site. However, as you can see here, at the moment this is still mainly a human guided process. That means first you have the planning. That means it needs to be planned from which point are these done. This is then what Joel was mentioning with the pen and pencil. That means you for planning. Then before the robot, someone, that means a human worker, was using then the sensors on site. That means he had to go to the pre-planned point. He had to install the sensor. He had to run the data acquisition, and then finally at the end, you can imagine that means all of these data are then brought back to the office, and then the data has to run in order to fuse then the digital construction plan and the 3D point clouds. And I think we are here on a transition phase. It means the first definitely is to replace the human worker on site by the spot robot. As Joel was already explaining, the basic reason for that is, first of all, it's very time consuming to do this by humans. That means doing this with robots. It's you can use the worker that you normally would need to do that for other tasks. And while other people are still working, the robot can somehow walk around and do the inspection. However, you see that still the planning for the moment would be done somehow manually with another planning tool, and also the data processing still would be done also manually. That means finally, and I think this is also, as I understood, the vision of Stuga Lux, but could also be a vision of construction companies, is first of all to automate these generation process of these digital twins. That means the planning, in principle, could be done by an intelligent software. The robots need to have a higher degree of autonomy in order to do the data acquisition. And finally, at the end, of course, no person should do then the data processing. Also, this should be automated. So that means this is the generation of these digital twins. However, as you can see here in the middle, this is just only one potential application of these robots, because there's a huge potential of using robots also in the real construction work. But of course, I can imagine, or you can imagine, that this is really the future of construction. And the idea here is, first of all, to realize a higher degree of autonomy for these mobile robots on site. And in order to do so, we have three, I would say, core components that we are now going to realize. That means, you see, we are at the start of this collaboration, and the first project objective is to do the robot motion planning, but to automate the robot motion planning. That means, first of all, what we have to do, we have to convert the construction and the data acquisition plans into a format which is finally then usable by the robot. And as you can see here, this is a bit like the model, like the map that the robot would then have inside. It consists of different layers, where you have on the lowest layer, you have the real metric semantic mesh. That means a real map of the environment, which could come then. That means here it's really nice, because we have already a digital construction plan that we can reuse. Very often in robotics we don't have that. We have a total unknown environment. Here we are using that already, but then we are adding then also objects. That means there are humans on site or other objects. Then we have then places and structures. We have the rooms and we have the buildings, and all of these are then, let's say, converted into this kind of plan that the robot is then using inside. And with the help of that, the second big project objective is then the real-time localization of the robot. It means if the robot should have a higher degree of autonomy, it needs to be able to localize itself in the construction site, which is not easy because GPS normally is not working. That means what we are doing here, we are adding, as you can see here in the middle, we are adding some sensors for the, let's call it the robot intelligence. However, we are also to a certain extent combining the sensors, the 3D scanners that we are already using for the 3D point clouds. However, you can imagine that in order to use that for the navigation, we really need to step down with respect to real-time aspects and also with respect to resolution, etc. That means the idea is we will also add some additional sensors and then implementing some, let's call it the robot intelligence. That means the robot will have these sensing information on the real construction site, and he will then compare it in real time with the internal map. However, in addition, not only comparing with the internal map, but even adding then what he senses to this map. That means this is a kind of continuous process of localization and also map building. So then finally at the end, of course, here the output is then the localization of the robot. And if the robot knows where it is, then of course we can also then create automatically and even on-site and in real time an autonomous collision-free navigation, also following the data acquisition plan. But you can imagine in the original data acquisition plan, you only have the spots where the robot should go to. And on the real construction site, you have people running around, you have unforeseen obstacles. And this is also something that the robot then has to avoid and has to plan. That means also this is a kind of continuous replanning, which also requires then some let's call it robot intelligence, which is built in the robot. And as you can see, with all of these three cornerstones, I would say, with the three building blocks, we then will be able to at least collect the 3D point clouds in a full autonomous way. That means the idea at the end is a worker on site, even not trained at all with robots, will press a button and then the robot starts, goes through the different floors, collect the data, finally at the end comes back, and then at the end is ready to transmit the data and is ready to be transported perhaps to another construction site. So this is overall the plan. As I say, we are at the begin, but we have already a lot of experience with robots, and therefore we are now really happy to be able to collaborate and of course finally also to play around with these really fancy robots. Then thank you. That concludes my presentation, and hopefully there will be questions from the audience.
Thank you very much, Holger. So I invite Joël back, there he is, to join us again, and Holger and Jean-Paul to moderate the Q&A. I've seen there's a few questions that already came in, so feel free to add your questions in the Q&A section on the right-hand side of the webinar screen. And you can also like them with the little heart function, so we'll see how many people actually are interested in the same question as well. Over to you, Jean-Paul, to moderate the questions. Thank you.
Thank you very much, Mark. And also thank you to Joël and Holger for this presentation that shows also how the private sector and the research can work together. And that is also one of the functions from Lux Innovation, to bring those two worlds together. And here we have a really exciting example. There is one interesting question from the audience, and I think there is a short answer to that is, well, scanning generates a lot of data for analysis, visualization, and simulation. It requires more and more computing power. Will the upcoming Meluxina high-performance computer be an opportunity for new, better simulation and data analysis and new horizons? Who would be able to respond to that, Joël or?
May I? I'm pretty clear on that one. No, the answer is no. And why? Because we just not only need the computing power, but you need also the form, the containers, and the handling of those of that data. And so for the moment, we are simply subscribing to an Autodesk Cloud and Autodesk University. It's a very, if you're interested in this subject, also on construction and so on, I just can recommend it. It's this evening. It's free. If you go on the Autodesk site, you will see it. And tonight, they're going to announce a few things, a few extra tools that will help us in our process. And more I cannot tell you for the moment.
Okay, thank you, Joel. You, Holger, very briefly?
Yeah, I would say, so from the practical point of view, as far as the BIM is concerned, I fully agree then with Joel. Of course, from our side, for the robotic part, we are already using then the HPCs a lot, for example, in all of our, in order to develop these robotic functionalities, before you go to the reality, because before you go to the construction site, you normally then test your software in simulations, and of course for these simulations they are a bit disconnected from the BIM, but they are then connected to the robotic functionalities. In order to do that, in order to test, for example, then sensing and these intelligent functions, there we are already using simulation tools, which of course are then already running then also on HPC. Yes.
Okay, thank you. One last question, although there are many more, and I think we can respond to those later on offline. But an interesting one, I think, is saying from legal and regulatory aspects, is there any change in the regulations using robot in the construction industry planned at this stage? For example, requirements to monitor robots, license for robot use, etc. Joel, do you have a view on that?
Yeah, the view is pretty clear. My view is basically it's a tool, and we started with simply a digger or a shovel. Then we came to the mechanical digger, and now we come to the robot. And there are certain regulations in place how you can maintain and what the safety is concerned about the diggers. But there's no specific one, and that's one of the questions we were discussing when the minister visited us last time a few weeks ago. That yes, it is a problem, and yes, it is hindering us. That we have to have everywhere, even on an empty construction site, we still have to supervise the machine. For the moment, that's definitely an issue, and it's hindering the progress in innovation. But I'm pretty sure that the message was passed, and that's something where we gonna advance in the next few months.
Okay, thank you very much. As said, there are many more questions, but due to time reasons, we will answer these offline, and I will hand over now back to Mark for our last presentation.
Thank you, Jean-Paul. Just to let you know, yeah, that as a discussion is very interesting. We can also kind of like move the discussion afterwards into the group room, so you can continue to discuss subject matter for those who want. So this, let me pull back up my presentation and share my screen with you. 1 second. Here we go. So we had the presentations from Joel Jones, CEO from Strügerlux, the one from Holger Voss, and the Q&A session. So now we're moving on to the next and last speaker for this webinar, Pascal Steichen. Pascal will be talking about new technologies, old risks, so the IoT in and security. Pascal holds a master's degree in astrophysics, actually. And in 2002, so nearly 2 decades ago, he joined the Luxembourgish government task force for e-Luxembourg. Afterwards, he was an advisor at the Ministry of the Economy and project manager in the area of network and information security. And from 2003 until 2014, he was also a member of the management board of ENISA, so the European Network and Information Security Agency, Today, Pascal is the CEO of Security Made in Luxembourg, the structure behind the main information security initiatives of the Luxembourgish government, such as CASES, Circle, Be Secure, and the Cybersecurity Competence Center, C3, which was launched in 2017 as a European-wide unique facility to empower the Luxembourg economy in the field of cybersecurity. So, Pascal, I'll hand over to you after that introduction. I think when people have problems in terms of security with the Internet of Things, it's kind of like you are the person that they're going to call. So over to you to share your presentation with us, and we'll do a Q&A with you afterwards as well. With Jean-Paul. So that's it for my part. I'll say goodbye for now, as Jean-Paul will then take over afterwards and also do the closing part of this webinar. Keep checking the polling, as we will be adding a couple more questions where you can participate in the poll. Thank you. Pascal, over to you.
Thank you very much, Marc. Happy to be part of this Smart Manufacturing Week and this special webinar about the processes. I will talk about a bit more about software. The presentations you saw just before were more on the, I would say, the practical industrial hardware part, and I would like to address the cyber, the software, the IT part in the smart manufacturing, because when we as society add the smart to all the different areas that we develop or that we digitalize today, well, it's the digital part. It's putting IT, it's using technology to enhance, to better do the different processes that we are doing, or to create new ways of developing our businesses, as we have seen a few examples just before. And this is, I would say, what you probably heard, or what we call the Internet of Things, because the things, these machines, these robots, or these industrial machines, well, they have to communicate between each other. They have to share data. They have to interact with the operators, but also between each other to make the complete process as automated as possible, as we have seen a few examples. And so we use the interconnection that is being used is most of the time the internet, because that's the platform, that's the connection system that we have today, and that is all these machines are using the internet to interact, which makes it, I would say, very interesting, because one can be very international and very, I would say, scalable when developing the projects. But and that's why I'm here. It makes it also, I would say, kind of risky, because a lot of other things happen on this same internet, on this same platform, and especially as I think probably most of you are aware of, there is a lot of criminal activity going on also on this same internet, so on this same platform. So when we put sensors, microcontrollers, and all these things into normal objects or into existing objects to upgrade them, to make them smart, or when we create robots, as we have seen just before, and connect them to the internet, well, there are some risks to this. There are some security considerations that is important to consider. The major risks, I would say, I just wanted to give you a high level overview about the major risks. What could happen? There are some which are more from the user perspective side, from those that use these technologies, that use these devices, and also some which are more from the provider side. So it's a little bit of mix. So one of the major risks is obviously that, well, these devices, as they are connected to the internet, there needs to be an account somewhere to control these things, be it on site, be it from remote. And these accounts, well, these could be hijacked. They are protected by passwords or by hopefully some a bit more advanced authentication systems. But I would say this is a potential attack vector, as we call it. So this is a potential risk that someone else uses the account and controls the device to do different things or to abuse the device. With this comes then obviously access to data, access to I would say professional intellectual property data, but also to privacy related data when depending on the devices, and this can be obviously abused. This leads then, if it is done, I would say on purpose and on a large scale, this leads then to, I would say, intercepting a lot of data, to intervene, to even go into the direction of surveillance. All these are based on examples of real attacks that have been seen in the last years with such kind of devices. Another way how criminals use such devices is, I would say, not to interact directly or to get access to data or to the victim's network as such, but to use the devices as rogue or so-called zombie devices to use them to attack other potential victims. And so when having such an issue, when I would say being the victim of a cyber attack, of a cyber incident, does not always mean that you yourself are the victim, but it can also mean that you are the attacker, because your computers, your devices are being used to attack someone else. And this special case, we have seen it some years ago, 2 or 3 years ago, where hundreds of thousands of small devices like surveillance cameras, like dolls, like baby phones, like video recorders, smart TVs, that kind of, I would say, normal home devices, have been hacked altogether and used all together to do one huge big attack. So this is, I would say, a more general, more society issue, and that's where it is important that all we that are involved in this, I would say, take our responsibility and make sure that we protect the different devices. More on the I would say more on the provider, on the side of the manufacturers. I would say there are obviously risks to the supply chain. So the supply chain is an important element. All the different processes, all the different elements have to work together and have to, I would say, relay data, have to trust each other, so to say, so that the full manufacturing process is being of quality. And if this is compromised, if there are one of these devices which do not do their job, well, this can be an issue, and the end product can be defect, or it might even be a way to inject some, I would say, hidden elements that will not be discovered immediately, but only later when the device is being sold to customers. The example of this massive botnet DDoS, that's the example that I just gave before. And then obviously there's also physical attacks possible. We have seen a few examples. There can be, I would say, physical issues, but also there can be an criminal or a malicious attempt and physically attack such devices. Up to, happily today, there is no real example of this, of human casualty based on a cyber attack, but this might come sooner than we think, unfortunately. One example being smart medical devices. Also in the in the health sector, more and more of these devices get smart, and here you see an example of a smart pacemaker. A pacemaker, which is a device that we will have in your body, that will make sure that you continue to live your life properly. And today, these devices are connected to the internet, have Wi-Fi antennas, and I would say can be even controlled from remote by the doctor to adjust parameters, which is great, which is, I would say, comfortable for the patients. But if it is being controlled and abused by not the doctor, but by someone else, obviously this is not a good idea. I'm talking about this because that's already 7 years ago. Here in Luxembourg, one security researcher presented how she analyzed her own pacemaker. Obviously, she didn't hack it because she would not be able to continue presenting, but she described how she analyzed it and what was found. And in fact, she found more than 4 very basic vulnerabilities, like default passwords, like easy data not being encrypted, etc., with her own pacemaker. And so I would say she was quite alarmed about her life based on this analysis. So after the risk, after the bad news, let's have some good news. There is a lot of things that one can do to avoid all this. A few recommendations for users. So for I would say everybody outside who gets his new smart device, make sure that you protect these devices with strong passwords. Okay, it's like a computer, it's like a mobile phone. Use strong passwords. Strong meaning, you all know what it means. It means long, complicated, and difficult to find out by memory. Then another very important thing is to keep these devices updated. So the software and the software part, which is often called firmware with IoT devices, also needs some updates. Even if it does not, I would say, notify you as normal computers would do. Normally, one has to check by itself, but I would say keep in mind that this is important to do it regularly. Then when putting such devices into your network, into your office, for instance, it might be useful to, I would say, to create clear segmentations of the network so that such a device, like for instance a surveillance camera, which is outside of the building, which can be, I would say, tampered with from the outside, not from someone not being present in the building. It would be interesting to have it in a specified network so that if there is a tampering, that it cannot impact your normal business network, for instance. So one example. That is in line with the physical security aspect. So we have seen examples of people putting such video cameras on their house, and the network connectivity is outside of the house, which is not a good idea, because then I would say the criminal could, or someone could take out the video camera and connect his own device to the network and is in the network of the house. So these are also considerations, not only software, but also hardware, physical aspects. And then the legal part as well is important. So contracts, the terms and conditions, all these things are, I would say, quite important, especially if you are concerned about privacy, if you're concerned about your data. There is an interesting example of a doll, so a kid's device, which had camera and microphone incorporated, and which could talk to the children and do some little films, etc. And this device was connected to do that, was connected to a cloud platform. This cloud platform was being hacked, and all the pictures of the children from many places that had bought this were public on the internet. So that's quite annoying. So there also it's important to check, I would say, the contract, but also the suppliers, the providers of such devices. Are they, I would say, do they have specific security standards and processes that they follow and that they show also to their customers to create this trust? And then last but not least, if you don't need it, don't use it. I would say an umbrella with a chip that tells you when it rains or when the sun shines is not very useful. So try to avoid that kind of IoT devices, which exist on the market, however. From the provider side, there is a huge effort being done by ENISA, so this European Union Agency for Cybersecurity, with a lot of documentations, with a lot of recommendations for different areas that can help providers, that can help manufacturers, that can help all people in the, I would say, in the sector, in the economic sector of smart industry and IoT, etc. I would say, to get kind of checklist. Here, a little extract of one of the latest documents that was published 2 or 3 days ago, about the process. So about the manufacturing process of smart devices and what should be really important. Here, I extracted really the process aspect. The very first one is security by design. You probably heard about that by design thing in the context of the GDPR, the privacy by design. Well, in other areas, the by design, it should be important. We have seen in the very first presentation also the speaker telling that if you integrate into the design phase some of your reflections according to faulty and to defective production, it's more easy and less expensive to avoid faulty products at the end. Well, with security, it's exactly the same. As early as you integrate security into your project, as easy it will be, as less it will cost in the end. This includes, I would say, sound data collection management, or data sound management of data. How is data collected? How it is managed? Where it is located? How it is protected also, because it is not only the confidentiality aspect of data, which is linked then to privacy, etc., but in industry, it is mostly and mainly the integrity element of data, so that the data is correct, because all the engineers in the room or in the virtual room know that, I would say, data figures where the comma is moving can have a huge impact. So that accuracy, that integrity of data is really quite important, and this is also part of security, of cybersecurity. So the integrity of the complete supply chain is quite an important aspect. Then obviously you will not create everything by yourself. You will use probably a lot of existing software, or with some elements, some robots, for instance, comes software, with some tools, with some technologies comes own software. So it is important also to check these software elements on their security elements. So do they have, I would say, kind of followed standards, what type of certifications they have, etc. So I would say, think about security in the whole project of creating of digitalizing your supply chain or your manufacturing process. Testing is also an important element, and security testing, I would say, so to at a certain point of time, try to test how your system, how your process will manage the fact that there is an integrity issue, or that there is one element which is not working well. So to make sure that you can have some, I would say, experience how to manage this if it happens in real life. And then I would say, when the device, or when your product, when you have your end product, whatever it is, it should have, from the factory, out of the factory, it should have security by default. So by design is at the very beginning, by default is at the very end, so that the customers that buy this object get the object with security functions already activated, that they don't need to activate them by themselves, because many of them will not do it, will maybe forget it, or don't care about it, and at the end of the day, it's, I would say, your manufacturing reputation which can be at stake. And then during the life cycle of the product with your customer, obviously make sure that you have a patching policy, that you have a process where you can inform your customers that there is an update. How does it work? How they can secure their devices better, or when there is an error or a defect has been detected, that you can make sure that all these devices can be updated easily. With software that's easy, it can be pushed via this internet, this international network. So it's way more easy than with physical devices. And I would say, to conclude, all these recommendations, all this awareness raising, so to say, will be done throughout this and next year. It started a few weeks ago, a national awareness campaign about the topic of IoT, so the Internet of Things. You find the website secure-iot.lu, where today we have, I would say, a focus on the user perspective. So we have the main area: smartphone, smart home, wearables, toys, but also the office. So more from the user perspective. And throughout the year, throughout next year mainly, we will add also the more Industry 4.0, the more manufacturing elements to this same campaign. So together with many experts of the local ecosystem, so probably some of you in the near future. So thank you for your attention, and if you have questions, don't hesitate.
Thank you very much, Pascal, for this very good presentation and insight into the cybersecurity aspects of IoT. There are a few questions from the audience. One is, what do you say, technical threats or regulatory threats, such as data privacy threat to the customer, you see more critical for IoT in the current context? So technical threats or regulatory threats?
Well, what we see, unfortunately, what we see today is a lot of technical vulnerabilities, especially a lot of issues with the IoT, with the IT, with the information technology part that is being added to devices. That we have seen many years ago in IT itself. So like default passwords, I would say basic security reflexes that are not applied, unfortunately. We see that a lot. So I would say at the moment, the technical part is really the most important because the regulation is lacking a bit behind, but one can expect that there will be more regulation coming, that there will be certifications, that there will be, I would say, European regulations. For instance, in the area of medical devices, there is one in the making at the moment. So this will come, but it will focus, I would say, more on the technical, on the safety aspects also, because there is this closer link with the physical world and with, I would say, safety of humans and of our society.
Okay, thank you for that. Another question related to the current COVID context is there any recommendation provided or planned to the Luxembourg companies using employees working from home during this COVID period? So is there something from your or from the ministry side planned to help the companies?
Well, from the cybersecurity side of things or perspective, I would say we have done some articles. We have published some recommendations about what is key, what is important if you work from remote, if you have, I would say, a distributed team throughout different places. So there are a lot of recommendations that have been shared, which are, I would say, which are basically the same than already many years are applicable. Now with COVID, it has just, I would say, it needs to be done faster.
Okay, thank you very much for that, Pascal. There are still other questions, and we will ask them offline as also proposed before. Also, during the rest of the day, the networking part and also the virtual booths are still there for you to connect and to ask your questions. And then, well, this ends today's webinar on smart manufacturing processes, and I hope you enjoyed it as much as I did. As you might have identified during the presentations, the role of Lux Innovation is to support these innovation and research projects with the various teams and services we provide. The company relation and support team that also organizes this week jointly is there to understand the problems of their clients and to initiate these collaborative projects. Just to mention the co-financing support, our Fit4 programs, and the Digital Innovation Hub to help the companies with their digital transformation and bring offer and demand together. Now the time has come to thank all the speakers again for their enriching presentations, our service providers with their virtual booths, you as participants, of course, Natalie, Roman, and Mark for the preparation and their support during this webinar, and the whole Lux Innovation team. So this was the second webinar of a series of 5, and I hope to have you with us again tomorrow at 11 o'clock, when we will talk about smart value and supply chains. That's all, folks. Stay tuned and stay safe and healthy. Bye-bye.